Hello everybody, this is Fadi Al-Turjman, the General Chair of EAI International Conference FoNeS IoT 2020. I would like to welcome you all in this international conference and give you my welcome message, hoping that you will enjoy it as well as the forthcoming sessions in this conference. It is our pleasure to welcome all of you to the first EAI International Conference on Forthcoming Networks and Sustainability in the IoT Era, FoNeS IoT 2020, which was supposed to be held in Antalya, Turkey, but due to the safety concerns and travel restrictions caused by the COVID-19, it will take place online in a live stream. The conference received in total 35 submissions from the international research community. The papers went through a rigorous review process where at least 3 reviewers are assigned for each manuscript. The program committee members as well as external reviewers have contributed to the review process. Based on the reviews obtained, 13 papers are accepted for presentation at the conference. The authors submitted the final camera-ready versions of up to 20 pages, resulting in an acceptance ratio of 37.1%. 3 candidates for the Best Paper Award have been also selected based on reviews, recommendations of the senior TBC members, and additional feedback from the organizing and steering committees. These papers will be announced in the last session of the conference. The accepted papers provide insight into the literature and findings in areas related to communication aspects, energy efficiency, and artificial intelligence in IoT, 5G networks, and cloud services. We would like to thank all of those people who contributed to the success of this conference. We thank the authors for submitting their works and the reviewers for their time in providing rigorous, timely reviews. We would like also to thank Dr. Schlamtek, the chair of EAI FoNeS IoT 2020 Steering Committee, and the conference manager, Natasha Onofria, for their timely guidance. We would like to have your engagement and informative feedback as well. We also wish you a pleasant time with this FoNeS IoT sessions. This is Fadi Al-Turjman and wish you pleasant time. Best wishes.
Ladies and gentlemen, let me welcome you to the EAI International Conference on Forthcoming Networks and Sustainability in the IoT Era, EAI FoNeS IoT 2020. I am Natasha Onofre, the conference manager of this year's edition. Unfortunately, due to the coronavirus pandemic, I'm not able to meet all of you in person. So I'm using this opportunity to address the organizing committee, the authors, and our online audience on behalf of the European Alliance for Innovation. Above all, I would like to express my gratitude to the General Chair, Professor Fadi Al-Turjman from the Near East University in Cyprus for his excellent work in organizing a successful conference in these difficult times. During this streaming, you can actively participate in 2 ways. Firstly, you can take part in the Q&A discussion on Slack by following the link below this video. Upon accessing FoNeS IoT Workspace, you will be able to enter all the channels, which are divided by sessions. Secondly, you can vote on individual presentations and leave your fellow researchers feedback on their work through our tool, EAI Compass. In a few minutes, we will explain how to access the EAI Compass and how to leave and receive feedback for presentations in this conference. Also, I'm very glad to be able to announce that the second edition of EAI FoNeS IoT will take place in October 2021 in Antalya, Turkey. I invite all of you to participate in our 2021 edition by submitting your papers, by organizing a workshop, or by joining the technical program committee. In fact, at EAI, we're constantly searching to promote innovative research in the field of information and communication technologies. So, if you have an idea for a conference or a workshop, or you want to collaborate with us in any other way, please contact me at the email address below this video. After my presentation, my colleague Michael will tell you more about the EAI entity, the tools we provide, and the aforementioned voting process, which you can already use during this conference. Thank you all for your attention and hope to welcome you again in Antalya next year. Enjoy the conference.
Hi everyone, my name is Al-Turjman. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello, everyone. This is Ahmed Abdelgawad from Central Michigan University. First, I hope that you all are safe and healthy. Today, I would like to talk about all what you need to know about Internet of Things in order to build your own IoT architecture. So I will start first to talk about the IoT definition. Then I will talk about IoT vision and enablers. And also I will talk about sensors and actuators, hardware for IoT, communication technology for IoT, different protocols for IoT. Also, I will talk about some software you can use for simulation for IoT. Also, I will talk about some cloud platforms for IoT and applications for IoT, and give you some opportunities for IoT. And finally, I will talk about the IoT challenges and how to overcome the challenge. First, the IoT definition. It's very simple. It's only two words: Internet of Things. And we all, what is the Internet? So Internet is a worldwide network of interconnected computer. And things is anything. From the name, there's no limit for anything. So things will use the internet in order to communicate with each other and take independent decision. So the idea is to move from Internet of People to Internet of Things. So things will take care of themselves and also take care of us to take the right decision in order to make our life easier, to save money, time, energy, and you name it. And as I said, things, there is no limit for things. Whatever you can think about could be used as thing. Even I have seen some people are connecting diapers to internet. it looks weird. Who care to connect diapers with internet? But you can imagine how much money you can save if you connect your baby's diaper with internet, just in order to change the diaper in the right time, not early, not late, because if it's early, you're wasting the diapers. If it is late, sometimes it harms the baby. So even if you save few diapers per day, so that's a lot of money. And if you avoid some health problem for your baby, it's a lot of money saving, because if your baby is suffering from something, you need to go and see the doctor, and it costs money. And even you burn gas to go over there, you pay for the physician, medicine, and many things. So, and imagine if every single family save one diaper per day, how much money we can save and how much energy you can save. It's not only about money as well, because we need to have a green environment. So saving diapers, that mean you save oil used for transportation, for manufacturing itself, and even the diaper itself, it takes time to recycle it. So it's it's a win-win solution. So anything could be connected to internet. There is no limit for things. So everything is connected, and we start to see this for everywhere. We can see smart home, smart car, smart city, smart TV, smart phone. Everything is smart right now. Even at home will be connected. Our home is equipped with many sensors that can save energy, can make our life much easier. And not only homes, city also will be connected. Everything will be connected together in order also to make our life easier. And even the world will be connected. Not only this, we also will be connected with things in order to check, for example, like if you are running, and you can check your heart rate, you can check how many miles you ran, and many other things, and you can upload all of this information to internet and use it later. So everything now is smart. But smart in Internet of Things, it has a meaning, different meaning, not the exactly meaning of smart, because um, for a certain extent, yeah, Internet of Things itself, it's not smart, but we can add some feature like artificial intelligence, some other algorithm to make it smart. But IoT by itself, it cannot be smart by itself, because smart means that you analyze data and take decision even without any previous knowledge about what's going on. But anyway, it's smart in IoT. When we call a device a smart device, that means it's connected to internet. That doesn't mean that the device itself it's smart, but the device itself has a capability to connect to internet and then use some algorithm, some other software to take a smart decision or to make it smarter. But when I have a smartphone, that doesn't mean that the phone itself is smart, but it has some capability to connect to internet and then make it smart. So the need to connect our asset came from us. Usually, when we wake up in the morning, we have a lot of questions. We ask ourselves, am I healthy? When is my next bus? Where can I park my car? Can I reduce my electricity bill? And many things. So, and usually we don't want to worry about all of this. That's the question came, why we cannot make all of these things take care of themselves and take care of us, and we focus on only one thing. We just focus on my job. So to go to my job and do my job, and about my electricity bill, my health, my bus, my car and stuff, they can take care of themselves. That's why we came up with Internet of Things, or the idea of Internet of Things. So what is the component for IoT in general? So the first component and main component in things themselves. So it could be a sensor or actuator, and also connectivity, how we can communicate things, how they can communicate with each others. We have many protocols or many modules for communication, Bluetooth, Zigbee, Wi-Fi, and many other things. And the third component is data, because again, we need to analyze the data, visualize the data, and then take action or take decision depending on data. And then analytics is the last component. So why IoT is at an inflection point? Because the hardware nowadays is very cheap. You can buy, for example, a Raspberry Pi with $40, for example, very cheap. And this Raspberry Pi is a very powerful computer. It has many capabilities, so you can use. And also connectivity is easy and plug and play. You can use it in any device, in any modules, and available and cheap as well. And development is easy. And the most important thing make it easy for us to have IoT is the Moore's law. That means that number of transistors are double every 18 months or 2 years. So that make all the devices or new devices has more capability than before. So what is the IoT vision? The vision for the IoT is to fuse the physical and digital world together in order to create a seamless network of billions of wireless objects. And these devices can be able to direct their transport, adapt to their respective environment, self-configure, self-maintain, self-repair themselves. So this is the main vision for IoT. And the IoT evolution started long time ago, since the pre-internet started with using SMS with our phone, and then we came up afterward with the Internet of Content by sending emails, sending some information, use the internet for entertainment. And then after a few years, we came up with Internet of Service, that we can use e-commerce and e-productivity. And recently, we start to have the social media and the Internet of People. We can use Facebook, Zoom, Skype, and many other things. All of this together lead to Internet of Things, which is machine-to-machine or thing-to-thing communication, and so on. So what is the IoT enablers? The first enabler for IoT is us as a consumer and producers. Because for human being, usually they're looking for new things, looking to improve their life. So we think about many application and many projects and ideas, and from this we can, we enable to have the IoT, and then other people start to think how to solve this problem. The second enabler is the smart devices itself. They are available and very cheap. Third enabler is the communication network is available, and you have many modules available in market with cheap price. You can use Wi-Fi, Bluetooth, Zigbee, and 3G, 4G, 5G, and even 6G in future, hopefully. The last enabler is the cloud computing platform. They are available right now, and even either for cheap price or sometimes for free. All of this together enable us to have IoT. So what is the IoT loop? This graph shows how the IoT is working. First, we sense the data or collect data. and then we communicate the data, aggregate data, store it on cloud or something like this, and then we start to process data, analyze data, visualize the data, and depend on this, we can take an action, and then again, sense again, and go to the same loop. So let's start to talk about each component by itself. We'll start with IoT sensor and actuators. And we start to see recently in the last decades, we start to see a lot of sensors available in the market and very cheap price. Like for example, 25 years ago, it was very hard to find a sensor for a humidity sensor or a temperature sensor available in market with available or cheap price. But now we have many sensors available in market with very cheap price, and even to connect it with Raspberry Pi or Arduino or any microcontrollers, it's easy to use it. The second thing we need to talk about to understand what's IoT, and I think also it's a good idea for you to think right now about a project you can do it in your lab or at home or in your car or whatever. Because I will walk you through all the component and what is available in market, what you can do, what is the challenge and stuff. And even if you don't have a very solid background about engineering or hardware or something, you still can do it because even young kids, they start now to play with this modules and stuff, and they can do some IoT projects. So it's not all about programming, coding, and stuff. Even if you don't have that much experience about coding and hardware and software, you still can do something with IoT. So the deal is for you to think about a project you can do in future, and you can start from now to think about this project, and then I will explain everything here, and then you can pick what you can do, and you can understand more down the line. And hopefully by end of this presentation, you will be able to have enough data you can start your own project. So as I said, we start to talk about sensors. So whatever project you can pick, you can think about what kind of sensor you can use. We have many sensors available in market. This is just few of them, but you can think about temperature sensor. You can think about relay. You can think about humidity sensor, 7-color flash, IR sensor, heartbeat sensor, and many things. But again, this is just few examples, and you can go and search for many other sensors depending on your own project. And if you cannot find the sensor, you can find a way how to get some idea how to collect data. This is again will depend on your project. After the sensors, you need to come up with some hardware or microcontroller or a module to collect the data from sensor and do some processing and send this data or push this data to the cloud. I'm showing you here a few examples of hardware, and this is some also other examples of hardware. But if you are a beginner and you would like to have something simple and easy, and you can find the code or all the software you need, you can go either by Raspberry Pi or Arduino. Also BeagleBone or Intel Galileo. These four are easy enough for someone who want to start to do some IoT project. So after you pick your sensors, you need to pick your hardware, which you will connect your sensors. And again, you can check also because some sensors, they are very compatible, and you can find all the software and stuff with one of these modules. You can check, for example, Raspberry Pi. And when you check Raspberry Pi, it can, or the sensor itself, it can tell you it's compatible with which module is compatible with which sensor. So when you pick your sensor, you can pick the hardware which make your life easier. So when you connect them, it's easy. You don't have to do that much work to push the data to internet. But again, these are a few examples here for some hardware you can start with. But in order to pick your right hardware, also you need to have some criteria to the criteria to use this hardware. The first one is the size, how big the size of your device, the final device, how much power you can consume, because if it's you don't have if you don't have a source of power and you will have a battery, so you need to think about how much power it will consume and how much time the battery will last. So this is also one issue you need to think about. The interface with the sensors, as I said, you need to think about it. Security, is this module has security or not, or your project needs security or not? Cost, how much it will cost you, depend on your budget and your project, and many things. So you need to think about all of this when you pick your hardware. So we finished talking about sensors and hardware, and the third part here is the IoT communication. So we have many communication protocols here. You can use it for your IoT, like Bluetooth, and Zigbee, Wi-Fi, LoRa, and the same story. When you try to do your project, you need to know how much, for example, for communication, how much data rate you would like to have, how much range you will use in your project. Like, for example, if you are using an application for agriculture, and this is you have like tens or hundreds of acres, you would like to do a project for IoT in this. So you need a very long range. This graph here shows you different protocols and for different ranges and different data rate. Depend on your application or project, you can pick the right one. Like, for example, as I said, for agriculture application, you can use for example, LoRa, because LoRa has a long range for communication. For example, if you use this graph, for example, if you have a very long range as well, you can use GSM, but the data rate is low. But if you would like have a high data rate, you can go with WiMAX, with high range. If you have a very low range and very low data rate, you can use Zigbee or Bluetooth and so on. So this is, again, depend on what kind of application or project you do. It's also good to mention something here about 5G, because 5G actually it came because of IoT. If you look here, the old version or the old 4G, for example, the latency was like 10 milliseconds, but 5G will be less than 1 millisecond. And the most important thing here is the connection density, because in future we will have many devices connected together, and in the same, like for example, in one room you could find 100 of smart devices. So this is a challenge for communication. Like for example, 4G, it can accommodate only 100,000 connection per kilometer square. But for 5G, you can have up to 1 million device per kilometer square. And even in future, we need more. That's why we start to talk about 6G as well. So we need more speed, more connection density, and even for data traffic and data rates and spectrums. 5G it's more compatible with IoT, and even we need to improve this more. So we'll start to talk about 6G. After you can pick your communication protocol, there are some standards, like for example, if you're doing research or something like this, if you would like to do some simulation or some research, we have many protocols here for like for example the RPL or the 6LoWPAN and IPv4 and 6. All of this is infrastructure protocols we are using for IoT, and many other MQTT and stuff, many other IoT standards and protocols. You can also do some improvement or research points here for example, for routing protocols and how to send the data in fast and many things. So these protocols and standards for people who ever want to do some research, but if you do straightforward projects, you don't have to worry about all of this. If you would like to do simulation before you do the real project, there are some software. I will show you here only a few of them. Like for example, if you need to simulate what you are doing before you do it in physically. So this Conteki software is a good to start to do some simulation, and it has some compatibility with some hardware platform. So you can because we have Tiny OS, for example, you need to check which one you need to use, Tiny OS or Conteki, depend on the compatibility with hardware you have or the microcontroller you have, because after you do simulation, you can download your software or use the same simulation code to do the hardware. So TinyOS is another one for simulation. After you collect the data, you use the hardware, you need to push the data to a cloud platform. I also collected here some of the available cloud platform, which you will send your data over there, so you can do store the data, visualize the data, and analyze the data. So here you can have Google Cloud, Microsoft Azure, Zebra, ThingWorks, and many of them. Again, I'm just collecting here some of them. These also are some other IoT cloud platform. ThingSpeaks is one of most popular within our students here at Central Michigan University. They are using this a lot. Another platforms here, Tempo also is a good one, which is they give you free code, free tutorial about Pi and sensors and Arduino and stuff. And it's a very friendly platforms that you can use even without any knowledge or experience about coding or how to run the platform. So this is these are the available platform in the market that you can use in order to send your data. So again, this is the entire story. You start from sensor and then connect the sensor to hardware and use a communication protocol to communicate the things together, and then push the data to internet using one of these cloud platform, and now you have your own data on cloud, and then you can run some other software to take the decision. This is the story for the IoT. As I said, till now, the device or the project you are doing is not smart yet. This is an IoT device, but to make it smart, we need to think about implementing some artificial intelligence or something like this. And artificial intelligence, it's like the brain of the body. So now, after you do your project, you collect the data, push it to the cloud, and then you need to run some artificial intelligence algorithm in order to analyze, visualize, and take action and make your project smart. And artificial intelligence, it has many branches and many things here. Like, for example, you can do deep learning, machine learning, and text to speech, and many things you can. I'm just get this graph here for you guys to understand if you have something related to artificial intelligence. So if you would like to do some research or some project, so you can connect, or you can find a way to find an algorithm for artificial intelligence. Another thing also related to IoT, which is the blockchain. And blockchain also came because of IoT to secure, or the idea came after IoT, because in order to secure some transactions or something like this, we need some new mechanism, and that's why blockchain could help IoT as well in order to secure transactions and other things. Something it's good to mention also to understand everything related to IoT. Like, we can hear about some terminology about fudge and edge, fog and edge computing. From the name, you can find out fog computing is something in the middle, because fog usually in the middle between clouds and earth, for example. So if you do some competition, for example, if your project, if you need to do some competition, or you don't want to do all this smart algorithm stuff in the cloud, you can do it in between at the gateway. And if you do it in the gateway, we call this fog computing for IoT. But if you do it at the device itself, if you have a Pi and you connect some sensor and you don't want to send the data to the cloud in order to take the decision on cloud, so you can take the decision on the spot at the Pi level or at the sensor level. So we call this edge computing. So this is a difference here: edge, fog, and cloud computing. If you do the competition or take the decision at the hardware or the sensor level, we call this edge computing. If you take the decision at the gateway in between, for example, we call this fog computing. If you do or make the decision at the cloud, we call it cloud computing. Another thing also came with the Internet of Things, which is Industry 4. And because again, we're looking for autonomous factories, and in future, machines are communicating with each other and finish the work or finish the job by themselves. So this is also something good to mention. The IoT architecture in general, just to give you an idea, or to divide it in different levels so you can understand more how you can come up with your own project. So we came up with an architecture or general architecture for IoT in 4 different levels. The first level is sensing and identification. Second one is network construction. And third one in information processing, and the last one, which is integrated application. And again, this is one architecture, and you can find different architecture from different groups, different people, but this is the main. All of them are almost the same idea. What is the IoT applications? Actually, we have a lot of applications for IoT. I'm just bringing here some of them, starting from consumer and home, also smart infrastructure, security and surveillance, transportations, and industrial application, retail application, and healthcare application, agriculture application, and many things. So IoT start to be in everywhere right now. So what is IoT opportunities? Actually, as I said, using some sensors and some processing unit or embedded processing unit with some connectivity, 3 of them, if you use some software, you can get many applications, many opportunities for IoT. You can do, as I said, smart health application, smart grid, smart home, smart parking, smart energy, and many other services. And I like this graph because it shows you or what is the opportunity or what is IoT. So it's very simple. sensors and some microcontroller and some connectivity, and put them together with some software. You can do whatever you want. But again, life is not easy all the time. We have some challenges here for IoT because the first one as well here for big data. We have a lot of data nowadays. We are collecting, even like, for example, for your smartphone, you have close to 9 sensors, and all of this sensor collecting data. And you can imagine like a full of 90% of all of the data in the world has been generated over only the last few years. And also it is estimated by the IDC that this year, 2020, end of this year, we will have 45 zettabyte of data. 45 zettabyte means that 21 zeros, so it's a lot of data. So how we can handle this data, or not only about storage, because storage is not a problem, how we can understand the data, analyze the data, visualize the data, and take the action, and even filter the data, because some of this data is not true, or how we can get the false data, how we can get the right data and take the right decision. It's very challenging, because again, the traditional algorithm to do data processing or data analysis or something like this won't work with this, because it's huge number of data, huge amount of data, and you need to come up with a new algorithm, new mechanism in order to give the right decision. Another challenge here would be security. Because, for example, if you have an application for health, like, for example, a pacemaker in your heart, for example, and it's connected to internet and it sends data to the cloud, and the cloud will run as a very smart algorithm in order to adjust your heart rate. And imagine if you are sleeping and your heart is connected to the cloud, and someone can hack the system and play with your heart rate and harm or maybe kill you. So this is dangerous. So we need to come up with some new security algorithm in order to fully secure all of these applications, so people can use it. Because right now, I don't think it's safe, or people will accept it to be fully connected to internet. Everything is connected to internet, especially for health application, unless we can come up with a very secure mechanism and assure them that they will be safe. No one will hack the system. No one will know about their own privacy or own data and stuff like this. So we need you also to come up with some new security algorithm and mechanism in order to make it more safe and secure. Another challenge is the bandwidth and power consumption. Again, the number of devices will increase dramatically in future, and the available bandwidth will be short. So we need to come up with a new idea how to increase the bandwidth and how to reduce the power consumption. Networking will be a challenge, because when the number will increase, scalability will be an issue, and diversity as well, and also how to come up with low power network will be a challenge. So this is also some area of research if you would like to dig more and find some new networking for IoT. Another challenge is the software. Like, for example, as I said, the Raspberry Pi or any of the hardware modules, when you connect your sensors and then run some mini algorithm, and even you can run some artificial intelligent algorithm and stuff, so you can find or end up with a code on your hardware with millions of lines. So how you can debug if there's something wrong, or when you download something here and there, and how to find the error and to fix it or debug your software, it's a challenge. It's not like before when we have a 1,000 line software or code. Oh wow, I have a long code and it was hard to debug and trace problems and stuff like this. But in future, when we will connect many things and we'll have a code or software with many modules and libraries and stuff, we need to come up with some new software which is easy to debug, easy to write, easy to use, and even easy for regular people to understand, because again, you will give this device or this application for regular people, so they need to deal with that. So we need to come up with new softwares and stuff in order to also make this IoT more available. Another challenge here is standardization. And standardization, because again, everything will be connected, and many devices will be connected together, and they need to have the same standardization in order for them to communicate with each other. They need to talk the same language. This is very important. Otherwise, when things if they don't have the same standard, so it will be hard to take the right decision. So standardization is very important, and we have many organization, they are working very hard to come up with some standardization for IoT, for communication, for hardware, for sensors, for many things. For example, IEEE, ISO, ITU, and they are working to come up with some standardization for future IoT. So again, the idea is all of us need to work hard to make our life easier and to save money, power, energy, and make a good environment for us. And we need again to work just to come up with some good applications for us. Like for example, if you see here in this picture, for future car will be fully autonomous car, and then you can sleep in your car, and then the car can go where, to maybe drop you off to your workplace and then go to parking lot, park itself, and stuff like this. But I don't think any one of us will trust the car right now to do something like this. So we need to work hard in order to make this available in near future. This is not an easy job to do it, because in order to sleep in your car, peace of mind, you need again to have a very secure system, so no one can kidnap you in your car and take you somewhere else, your car destination, to drop you off to your workplace. So you will find yourself in different destination. So you need to have a good security, reliable devices, and reliable sensors, and reliable hardware, so you can sleep peacefully in your car. You are sure that you will not be engaged in an accident, and many things. So all of us, I'm asking all of you to do more research, to do more project, to work more and more in order to make this car available in near future for us to use. By this, I'm concluding my lecture. Here is my contact information and my LinkedIn link is here as well. I like to be connected with you guys in near future. If you have any question, you can send me an email, or you can communicate with me on LinkedIn. I'll be happy to address your question. Thank you very much for listening, and you have a good day.
Hi, I'm Rosario Pulmone and show this paper with title Share a Design Pattern for a Dynamic Composition of IoT Services. The context. In this article, we want concern with the direct interaction between devices, with little memory, slow and unreliable or occasional connection. The connection determines the context. For example, when the device enter or switch on and or exit or switch off, the set of the mutual visibility change. If the device want to access to external device, this is not always guarantee. And then, if change the context, change also consequently the service provided by the device. In addition, the software inside the device can use other services and provide a service for others. We won't guarantee the usability, but at the same time, guarantee the code protection. For example, this is not possible if we use the pure code mobility. The state of art. This is many way for interact and implement services with IoT devices. For example, Amazon AWS IoT and Google Cloud IoT Core use a cloud repository, typically MQTT broker, but data protection is very difficult to guarantee. The framework OSGI and SM4All are sophisticated tools for dynamic composition services, but require considerable computing and memory power. WVSDL standard and ontology services have been proposed in IoT, but with little success. REST, HTTP and XML are proposed for IoT like business-to-business service, but require many resources. BPEL or Business Process Execution Language and WSCDL Web Service Choreographic Description Language are inapplicable for small device. And the orchestration pattern age use the framework Dr. Composer. It is not dynamics. The design pattern share is one metaprogrammic design pattern because it uses the code mobility for merge surfaces and is a dynamic composition because use on-the-fly composition like a merge for obtain the service when is called. Use the peer-to-peer communication because the rule for the exchange data between services is encapsulated in the partners. And self-care intentional property because the legacy code is bounded in the device. This is the class diagram of the shared design pattern. It's composed by three abstract class. When you make one services, you necessarily make an extension of the class services. In this class, there is one attribute, a string, and the name of the services. and three operations: function, daemon, and pre. The function describe the services for other services. Daemon is the code in device, stored in encapsulated devices, and the pre are the pre-condition for accept one call for another services. When you define one services, define the other service you need for execution of these services. Then create one, zero, one or more extension of the future. Future is the functionality called at other device and is specified by one ID, regular expression defined the semantics identify for this services called, one function call, and one post condition. The post condition ensure this value returned by call is uniform to service call aspect from the called. The call solve the identification and defined the new service you looking for in the visibility of the device. The class share is the repository for all service device interface exposed to other device and is composed by three operations: attach, detach, and discovery. Attach and detach is for to expose or expose the services. Discovery is a way for looking for a device in other device or in the same device. If is necessary, you call a service in the same device. This is the sequence diagram for the operation for use one services by another device or the same device. In this sequence diagram is specified by a call of the operation and the constraint in OCL languages for the specific operation call. Is you can to note in the this portion of the diagram, this is the core of the call for the services. In this way, it is send the code in the caller, and the code is the function find, but one discovery operation. This code is front end for communication with the other second side of the same function of the same services, or the daemon part of the services, and the client run the function send to caller and run together the daemon. In this part of the sequence diagram, it's possible to see the exchange of data for obtain the value in these services. At final, we looking for and execution the post condition, the proposition, because is not ensure the value return for the interaction is good for the color services. If this if function return true, the value is used for the rest of the program in the color. For explain this pattern, I propose one example, simple example, with three devices. Device A, device A looks for a service to calculate hypotenuse of a regular triangle. Device B exhibit a service for calculate the hypotenuse need for the execute function, and device C exhibit a service for calculate the SQRT function. This is the code for made one service for the calculation hypotenuse service. In this branch of code, there is the construction on the service by the operation new. In this operation, I define three pieces: the identification service by 1 to 1.4.3.6 is defined the name used one MIB expression. MIB expression is one identify method for object identification in request for comment 2578. And the function, there is the front end for this service, and the daemon is the second piece of the definition for this service. The daemon is the function stored in the device. Then the function is the code mobility with the run in the call service. In the daemon, we can see the construction of the feature because it's necessary for run this service. Used one another services for calculation square root. For the square root, we define one string 1.4.5.6.star. There is a regular expression to match any service with this specification, and the post condition function for ensure the value return for the call in the other service is good for this calculation. The same way for define the square root service. The instruction is the same of the device B, but in this code is defined the way for exchange data between the function and the daemon part of the code. The function for connect to daemon used TCP connection, and TCP connection is used by daemon for exchange data to caller. Then we have tested the pattern used wildcat platform. Wildcat is one open source device and code for make a simple IoT device. Used one SP32 microcontroller, and in this device run real-time operating system in Lua, a Lua interpreter for run code. The same pattern is implemented in Android smartphone using the Flutter and Dart. There is two tools provided by Google for make the interface, user interface, and for made the code in open way. In Android smartphone is load also the Lua interpreter. For the case study, we used 3 Wildcats and one smartphone. The Wildcats in Wildcats made the service for provide temperature, humidity, and switch on, switch off LEDs. And the smartphone provide the value of accelerometer and Stethoscope. And the smartphone made the service for looking for Wildcats, for found temperature, for calculation average, and etc. In this service, for 2 composition of service, we have a calculation, the value of the time necessary for calculation. It is less or equal to 4 milliseconds. The conclusion, share is simple, but required language for metaprogramming like Lua, Rust, Lisp, Ruby, Perl, Python, JavaScript, and also Java after-date version. Not necessary the framework, is modular, is safe, and it's possible to make the fault tolerance if duplicate the device. The future work, they resolve the loop of the service when the service call another service, and then service call another service, and they make the loop. This is resolved by introducing identify tracer for the call, and improving the performance for not make a discovery say if the value is just known by the device. Thanks for Francesco Coppola and Stefano Perliona for implementation the share on Wildcat and the smartphone. Thank you.
Hello. Today we have survey title from traditional house price Appraisal of computer vision based a survey presented in EAI FoNeS IoT 2020 conference by Nasser in October 2020. Outlines, we have introduction, methods, discussions, conclusion, and reference. Introduction, prediction of price a house is not an easy task. It requires a lot of variables to be looked at. Several researches have been carried out to provide simple and reliable house pricing platform for both realtors and their clients. Majority of the extended platform as based of traditional hedonic methods which are statistically based with evaluation of the digital image processing, computer vision and IoT technologies. The task is made easier for both the realtor and the client to find the house price. Using visual and time series data. In this several the trend in the housing appraisal prediction from traditional method to the computer vision based are presented. In the methods in determining the price of houses, there are several factors to be considered, both from the house interior and exterior. This include econometric and demographic variables. Econometric and demographic variables include population, size of house, years of building, design location, carbon emission, and cost of living. Interior features include the floor, type of furniture, paints, decoration design, number of rooms, reception, heating system, toilets and bathrooms. In external features include the building quality, street views, natural landmarks like castles, green areas, the athletic fields, and the house external feature around. In methods, again, the traditional methods which are statistical work based on econometric and demographic variables. Artificial intelligence methods also use econometric and demographic to make prediction of the price. Computer vision based approaches use the house interior and exterior images. Such studies demonstrated great performance by using visual techniques information. The advent of powerful computers have made it possible to use deep learning algorithms for the prediction of house price based on econometric and demographic and image feature. Case studies in this area are summarized in table number 1. In first column we have reference, and second, third, and fourth column we have techniques, data, prediction that used in this reference. In technology, some reference use dynamic model averaging, or another reference use Bayes or CNN, RNN, CNN, different techniques. In data columns, some reference use time series, another use image, another reference use both of them, image and time series data. Prediction, we have macroeconomic and demographic in first reference. We have locational and structural characteristic. In another reference, we have visual features, different prediction. In the last columns, we have case study of area, some reference in the USA, another reference in the Europe countries, and last one in the China. So in discussion, the traditional method don't include visual feature of the house to the buyers unless they go around the neighborhoods, which is difficult. The computer vision based that used images shows great performance by using visual techniques. It improves the understanding of the houses. Using the econometric and demographic data as well as the image data has proven to be more efficient of house pricing. In most of the computer vision based approach, data is stored in clouds. The personal computers. Clients are required to contact the relator if the agent doesn't provide a web platform. The client can access a web platform in which it has access to the data stored and processed in the cloud using reliable technologies. IoT as an emerging technology can provide high capacity storage, big data analysis, reliable, fast, efficient and user-friendly device that can exchange data to any point and location in time. In conclusion, the future of computer vision based in the industry of real estate is very bright. The computer vision information from scene can be extracted and be used for proposed of house pricing. Also, it is easier for the client to have a clear insight of what they are intending to buy and them. In conclusion, more of rents should be given to the area of computer vision in housing pricing, like setting data sets, algorithms, and integrating IoT technologies to the system. Finally, we have reference. Thank you for listening. Thank you so much.
Good day, everyone. My name is Ahmed. And my co-author is Camille Demila. I'm here to present student grade prediction using machine learning in IoT era. Here I will take you through this slide. We're starting with the abstract, the introduction, the aim, the methodology, the result, and finally the conclusion. Here we start with the abstract. Here, the work proposed in this paper is the application of machine learning technique in recognizing patterns and predicting student success rates. Utilizing this machine learning algorithm improves predicting student grades efficiently. The ML, it was implemented on two main courses, the Portuguese language and the mathematics. In this paper, we used four ML techniques. These are the machine learning techniques. We use the linear regression, the support vector machine, the neural networks, and the key nearest neighbors. The result gotten shows that student success rates can greatly be instigated by their previous performance. This study is set to increase student performance greatly if taken into consideration. The next on the slide is the introduction. As we know, tertiary institutions are priority stations for greater knowledge. School dropout rate is a problem in every university, and in early years of studies due to the lack of support during their undergraduate courses. The first year undergraduate is also referred to as the year of make or break because of this problem. The significance of this grade prediction is to minimize the rate of dropouts and as well as providing follow-ups for students for educational system improvement and improve their success rate. Based on the stated principle, we are going to utilize machine learning techniques in recognizing a pattern while predicting student grades, following several attributes in regards to their performance academically. Then the next on the slide is the aim. Here the aim, we are going to categorize the different procedures for ML techniques in predicting the grades. We will outline patterns gotten during the prediction. We will illustrate and analyze the results. And finally, summarize issues and challenges in this paper. The next on the slide, as we can see, is the methodology. In this paper, a guided methodology will be shown on the figure below. We're going to show it on the figure below. The data cleansing and the collection of historic data sets of student grades takes effect. The technique of machine learning is selected. The model for student grade prediction is gotten from the previous data being processed. The obtained results are visualized and analyzed. As we can see, this is the illustration. Firstly, the school management system. We collect data from them, we process the data, that is removing hindrance of the data, removing data, removing information that are not useful from the data, or removing duplicated data. And finally, we arrive at the final data set. Then the next phase, we select the ML technique, which is the supervised learning. And thirdly, the experimental process. We experimented it in VS Code, that is machine learning in VS Code. The results is going to be analyzed. In the fourth section, we load the data into a visual data application so we can visualize this data graphically for easy understanding and easy explanation. The data set utilized in this paper is poised of the instructive information of 355 students. The total record of grades of the student is 6,359. This correlates to the courses of the student. The attributes of this data include grades of the student, demographics, school, and social relevant features. And it was gathered by making use of data from the school. As we can see, this is a sample of the data set. G1, this is the initial grade, the first initial grade. G2 is the second, while G3 is the cumulative, the third exam that cumulates the first and the second grade. As we can see, the study time is in hours, the failures, the amount of failures, and the absence, the amount of absences. This is of 5 students, and you can see the marks given to them. The experimental process. During the test stage, before utilizing the ML technique, an investigation was done in gathering the information to rapidly distinguish students with specific type of conduct. Here, as we also remove duplicated data or data that are not useful for this process. During this task, it has the chance of recognizing similarities with comparative qualities, which can be applied as a beginning point to investigate future forecasts. In a subsequent stage, utilizing the regression method against the attributes. With this, we are expecting the measure of students who pass the subject to be distinguished. After utilizing the ML, the regression, we can now visualize the students with the pass grade graphically, and we can distinguish them from each other. At that point, it is an expectation endeavor with different evaluation and qualities. After recognizing the pattern, utilizing various significant attributes against the G-trait, that is the final grade, the models were also tested in various machine learning techniques, namely the LR, the KNN, that is the key nearest neighbors, the SVM, support vector machine, and the NN, that is the neural network. With these, we could depict the best model. The results will be discussed below. Here we can see the computational environment. The experiments carried out in this paper were implemented using the VS Code. That's the Virtual Studio Code. The Virtual Studio is a no-pay and a standard programming condition consisting of a solid suite of instructions for information examination and factual methods. This VS Code can be implemented on various platforms like the Windows, the Mac OS, or the Linux. TensorFlow for VS Code is a library that sets forward many thorough capacities for regression and classification tasks. In particular, the library makes use of linear regression, NN, that's the neural network, KNN, the key nearest neighbor, and the SVM, the support vector machine packages. Although the present implementation wasn't built in the light of execution, but summarizing the patterns and the best model. The operation of this task was evaluated on a PC with 2.6 GHz and 8 GB RAM. Here, we are going to analyze the results. So firstly, since we're recognizing the pattern, firstly, we have to extract the features. Secondly, recognize matching patterns. Thirdly, memory reference templates, like get the template and compare it against each other. And finally, we make a decision in finding out the closest, nearest reference templates to the given input patterns. So after the experimental process, we got some graphical illustration. Here we can now check and analyze the pattern in these images. You can see here we are looking at the final grade against the study time. This is the hours spent in studying. You can see 1 hour, 1.5 is 1 hour like 30 minutes. 2 hours, 2.5, 3 hours, 3.5, 4 hours. And you can see the final grades. The highest being 20, the lowest being 0. You can see the amount of time spent in studying increases the chances of getting an higher grade. Although the students with minimum study time, their grades were still reasonable, but couldn't get the highest amount of grade, as shown with the study time of 4 hours. So the second, we can see the final grade against the failures. The amount of students that failed in the final exam was minimal compared to the amount of failures. You can see failures were minimal. And here, this is the final grade against the amount of times they were absent. You can see the amount of students that spend the time in school. You can see the pattern got in here, that their final grade is high due to their minimum status of absence in the school. You can see the highest amount of absentees. Even got an average, below average mark. But you can see with the pattern got in here, the amount of people present in school got high marks. After recognizing the patterns, the whole data collected in this research was split into 90% training and 10% testing subsets. And the neural network, the LR, that is a linear regression, the support vector machine, and the KNN, that is the k-nearest neighbor models, were built with utilizing this split. After applying cross-validation, the assemble method was used and combines these 4 machine learning algorithms to get the goal. Here we show you the depiction of the assemble method. You can see the data sample, then we categorize LR, SVM, NN, and KNN. Then we ensemble this to get our appropriate output. You can see the 90% split prediction assemble mode. And here it's illustrated. We can see the accuracies of various models, carrying out 4 experiments. Experiment 1 with all the variables except D3. D3 we know is the final grade. Experiment 2 is similar to experiment 1, but no G2. Experiment 3 is similar to experiment 2, but no G1. So we tested this method without the significant pass mark, G1, G2, G3. By experiment 4, it's with all the whole variable. So we can see the best models is the LR. After ensemble method, you can see is the LR. The first experiment, the best method was the NN. The second experiment, the best method was the LR. The third experiment, the best model was still the LR. And the fourth experiment, the best model was still the LR. With this, we know that NN took second place, followed by the SVM, and finally the KNN. After building the models, they have been assembled into the final prediction system. It is observed that the data is almost linearly separable and a good accuracy is obtained using the LR, as shown in the table. Thus, with the other models used with the given data to predict the accuracy, there were still good prediction in contrast to the LR. There is no general most ideal decision for the K, that is the KNN. It differs from information to information and is normally decided through it and preliminary mode. However, it makes limits unmistakably. We tried different values with different estimation of K, which are odd numbers up to 11, but the best of K is K equals to 13, and we showed you in the table as a table above. On assessing the final execution, models were tried and the data and assessment of the model was finalized by looking at the final results. And it demonstrated that in the table, KNN accuracy was the lowest and the highest and the best model is the LR. Then finally, the conclusion. Here we know education is a pivotal component in our lookup. ML methods permit a high-level method for extracting information from group information, offering a fascinating chance for areas with regards to the education system. As we know, we tried 4 ML techniques: the linear regression, the NM, the SVM, and the KNM. And we know the outcome gotten is practical in accomplishing high precision of forecast, given that the previous grades are known. This affirms student achievement is exceptionally influenced by their past exhibition. However, with recognizing the pattern, we're able to determine some factors that will hinder the improvement of student grades if taken into consideration. As you can see, the number of absentees and number of failures. More research is to be carried out to get more understanding of why and how some attributes affect the performance of students. Also, there should be a consideration in increasing the experiment capability to more schools so the student database can be enriched. This study is set to increase student performance greatly if taken into consideration. Thank you.
Hello everyone, my name is Shiraz Ahmed and today I will present our research article under the title is Classification of IoT Device Communication Through Machine Learning Techniques. Content of my presentation includes some motivation behind this research work, goals and objective, what was the real life research issue that we intend to solve. I will go through a small introduction of machine learning techniques and specifically supervised learning and unsupervised learning that I have used during this research work. Then I will go through the dataset description that we have built during our research work. I will go through the research that we got and at the end future directions. Motivation. Our research group is currently working on 5G communication, and in order to move from 4G to 5G, a research community suggested several solutions such as introducing millimeter waves, introducing small cell size, beamforming, etc. Massive MIMO is one of them. So, what is massive MIMO? Well, to answer this question, we first need to know millimeter waves, which are waves that has a very high frequency, but it can travel for a very short distance. Thus, due to its high frequency, it has the capability to transmit a high amount of data, so it can be utilized for 5G. And its problem for the short range coverage can be solved by the massive MIMO. A massive MIMO is basically increasing the number of transmitter antennas for the given area. If we look at the currently working 4G or advanced LTE, there are 2 or maximum 4 transmitter antennas. On the other hand, for utilizing millimeter waves, we need to deploy massive transmitter antennas. For example, we will deploy 32 or 64 or even 100 plus transmitter antennas. But how we would know how many transmitter antennas exactly we need for the given area? This is actually depends on the number of communicating devices in the given area. So for this reason, we need to know how many communicating devices there are in the given area, which type of communicating devices there are, either Bluetooth device or Wi-Fi device. For this purpose, we can utilize signal, as a signal has very different parameters, and we can take advantage of machine learning techniques to get this information, and this will really speed up researcher work. Goals and objectives. So to summarize the previous slide, we need to build a framework that can answer to the following 2 research questions. First, device detection and recognition in the IoT network. We need to know what type of devices, either it is a Wi-Fi device or Bluetooth device, and the framework should be able to answer this question to detect correctly either it is a Wi-Fi device or it is a Bluetooth device. Second, detecting the total number of actual Wi-Fi devices in the given area. We can also get this information how many active Wi-Fi devices there are in the given area. So I will go through a small introduction of machine learning. As you know, machine learning is a subfield of computer science and artificial intelligence that allow machines to self-learn from the given data and without being explicitly programming. So there are 3 sub-branches: supervised learning, unsupervised learning, and reinforcement learning. I will define each of them shortly in the following slides. Supervised learning. A supervised learning is based on the label data. So in supervised learning, we provide the model with some sort of label data, and the output is based on the given input. So we will teach the model if these are the inputs, this could be the outputs in simple words. And the first step is we need to have a data set. The second step is data cleaning. In data cleaning, there are two subparts like removing the constant value, because constant value in machine learning is not performing in pattern formation. So we will remove the constant values and we will deal with the missing values. The third step is feature engineering. A feature engineering is not always the case, because we use feature engineering for a very high dimensional data. Suppose we have images that are thousands in number and each image is 1000 by 1000 pixels. So if we have a data set of such type of images, it would be very complex. Then we should use feature engineering. But in our case, our data set is not that complex, so we did not use feature engineering. The fourth step is splitting the data. Splitting data is dividing the data set into training set and test sets. And training set, we feed the model with the training data, and the model performs some interpretation and it extracts pattern. Based on these pattern, then it performs some predictions. On the other hand, the test set is like a new data that we feed for the testing phase in order to check the model performance. Unsupervised learning. On the other hand, unsupervised learning is not that complex. Here we simply provide raw data to the model performs some sort of mathematical interpretation and it extracts features. It extracts patterns, and based on these patterns, it groups together data into several groups. Dataset description. There are a dataset description includes we will describe here the dataset that we have divided during our research work. So number of rows is 3384 and each row is a one signal. So there are 3384 rows in the dataset and each row represents a particular signal, and this signal is either from a Bluetooth device or from a Wi-Fi device. There are total number of 11 columns and each column is one of the parameter for the given signal. So there are 11 parameter, 11 columns, and each column represent one particular parameter. For example, the starting time of the given signal, the frequency, the popping spectrum, the modulation, etc. So these are the parameters that we have used in our model, in our training set and test set. Then signal type, we have for the time we have targeted two signals, Wi-Fi signal and Bluetooth signal. Split ratio is basically dividing the data set and the test set and our training set. So we have used 2080. In the 8% of the data set we train the model, with the 20% of the data set we test the model. And machine learning algorithms that I have used is supervised learning and unsupervised learning. In supervised learning, I have used two algorithms, support vector machine and k nearest neighbor. On the other hand, for unsupervised learning, I have used k-means clustering. Results that we got during our experiments for the first task, that is device detection and recognition accuracy. So for support vector machine we got 100% accuracy. For k nearest neighbor we used 100% accuracy, and for the second task, that is K-means clustering, which is identifying the total number of active Wi-Fi devices in the given area. So we got 100% accuracy. I will describe the results in a bit detail in the following slides. The first one is a device classification results, which is the first task. So for the first task, I used supervised learning technique, and in supervised learning technique, I have used two: support vector machine and k-near sniper. In support vector machine, I have used the accuracy, the sensitivity, and the specificity that we got are here. So the first one is sensitivity. So what is a sensitivity? Sensitivity, also called the true positive value, which means the framework identify a device as a Wi-Fi device, and in reality it was a Wi-Fi device. So for this purpose, the sensitivity that we got for Wi-Fi device is 100%. For the Bluetooth device, we got 100%. The second one graph is for the specificity, and specificity also called the true negative value. That means the framework identify a device as not a Wi-Fi device, and in reality it wasn't a Wi-Fi device, and the framework identify a device as not a Bluetooth device, and in reality it wasn't a Bluetooth device. So for the specificity, we got 100% specificity for the Bluetooth device and 100% specificity for the Wi-Fi device. Accuracy. Accuracy is actually the combination of both true positive and true negative, or the sensitivity and the specificity. So for the accuracy, for the Wi-Fi device, we got 100% accuracy, and we got 100% accuracy for the Bluetooth device. So I can say in simple words, our framework was 100% accurately identifying a device that it is a Bluetooth device and it is a Wi-Fi device. The graph in the below represent all in one. So it represents the sensitivity, the specificity, and the accuracy for the Bluetooth device and for the Wi-Fi device. So it simply represents all of the previous results in one graph. Canon is also a supervised learning technique. As I mentioned, support vector machine that I have used in the previous slides is a binary class classification problem, and Canon is a multi-class classification problem. So our problem is a classification problem, and it is a binary class classification problem. So I got 100% accuracy by using support vector machine, but in order to double check the results, I can also utilize k-near snipers because it's a multi-class classification problem. I have implemented the k-near sniper, and we got the following results. So for the sensitivity and for the specificity and accuracy, we got 100% accurate results for Wi-Fi devices and 100% accurate results for the Bluetooth devices. So it is a double check that our framework is 100% accurately identifying each one device type. Wi-Fi device detection results. So this is the second problem that we intend to solve. Here we want to identify the total active Wi-Fi devices in the given area that are currently communicating. For this purpose, we utilized the central frequency because the central frequency of a Wi-Fi device is always the constant. So if we have thousands of signals and we collected from 5 different Wi-Fi devices, if we cluster these thousands of signals into groups, we will get 5 clustered because the central frequency is the same. So I utilize the same principle and I target the central frequency. Then I cluster the data, and we got 15 different clusters. And actually we deployed 15 different Wi-Fi devices at different locations. Then we create the data set, I cluster the data set, and we get to know that there are 15 active Wi-Fi devices in the given area. If we look at the bars in the given graph. There are 15, so it represents 15 active Wi-Fi devices, and that is 100% accurately identifying. Well, for future directions, for future, we are planning to include cellular signals because at this moment we only targeted Wi-Fi and Bluetooth signals. But in future, we are planning to include cellular signals as well. The second task that we are planning for the future is precise location of the device in the given network. For example, we can utilize localization technique, and based on localization technique, we can accurately and precisely identify a device in the given network. For example, this is the mobile devices and this is in the given area. This is a Bluetooth device and it is in this area. So we are planning to include the localization technique for the future. And thank you very much for your attention.
International Conference on Forthcoming Networks and Sustainability in the IoT Era. Our presentation title is A Framework for Developing Healthcare Application Systems Using the 6 LoWPAN-based Wireless Sensor Networks. I'm Zhongwei Zhang, and I'm come from the School of Sciences, University of Southern Queensland in Australia, and I have another 2 research collaborators. Then their names are Jianxiong Wang from the different school but in the same university, and also one professor in China from the Hainan Normal University. With the current COVID-19 pandemic infecting millions of people around the world, no doubt that the healthcare industry almost in any country is experiencing a severe shortage of healthcare workers or healthcare providers. Today, my presentation will follow the following roadmap. First, I'll present to you some challenges which are faced by the WSN for healthcare. And then I'll present to you the standard or the protocols of WSN technology use. And then I'll present the implementing infrastructures of WSN systems, and then follow that, I will present to you 2 scenarios of WSN for healthcare configured. And then I'll conclude our presentation by giving you some conclusions or the future study direction. Now, first, let's look at some challenges which the WSN for healthcare faces. There will be more and more challenges which the WSN for healthcare phase as the scope of the healthcare services expanding. Currently, there are a number of healthcare services, such as health monitoring, and also another is the body health monitoring, and also at-home healthcare. And next one is telemedicine. And also the wireless technology which are used in the healthcare or medical services. This technology include MANET or WSN or IoT. MANET is our traditional mobile ad hoc networks, and WSN stands for wireless sensor networks, and the later technology such as IoT, which is the Internet of Things. And also these challenges are related to the wireless or sensing devices in the healthcare. For sure that more and more sensoring devices are being used in the healthcare systems, such as smartphones or low power and cheap devices. Definitely, there will be some potential challenges. For instance, the sensor devices are, some potential of intruding patients' privacy. Next, let's have a look the general architecture of WSN applications. In this application, normally you will see under the application, you have the traditional IP network infrastructure. So this one could be the internet. And then this internet will be interfaced with a gateway. This gateway will interface with a number of sensor networks. The standard and the protocols which the WSN networks are used, and we actually provide this protocol stack for the WSN networks. And this protocol stack have 5 layers as shown below. On the top layer, where you have application layer. And the application layer, you have a network layer or networking layer, which may contains UDP and ICMPv6 or IPv6 plus RPL. And below this networking layer, you have an additional layer which called a 6-LoWPAN adaptation layer. And the bottom layer is called IEEE 802.15.4, or the people normally call it ZigBee protocols. And this protocol contains 2 sublayers. One is MAC layer, and the next sublayer called physical file layer. And we will have a quick review about the protocol used in the proposed protocol stack. We'll take top-down approach. So the protocol stack is decomposed into first application layer and routine layer, routine protocols, adaptation protocols, and MAC layer protocol or physical protocol. As we know that the application protocol are mainly responsible for collecting the patient's vital data. Normally, each company in the ZigBee alliance have their own specification, but their products must be interoperable to their customers. In the routine protocol, the protocol mainly responsible for route the data from the wireless devices to the gateway, or to the gateway to the routers, or to the data center. And currently, we mentioned, and we can see there are two types of routine protocol or networking protocol, which is RPL and AODV-like, not AODV. And we will spend a little more time talking about each adaptation layer and the MAC layer and the physical layer. Let's look at the multi-hop routine protocols first. As you may know that ADOV is an efficient multi-hop routine protocol for the MANNet. MANNet is a mobile ad hoc networks. However, ADOV only works on the ad hoc networks and where the IPv4 address schema is used. And also, ad hoc networks are mainly the computers or laptop, and they don't have the constraint of a power supply, and also they may have no limited data processing capability, limited capacity of data processing or the communication. However, the wireless sensor network don't have this luxury. So because the wireless sensor networks have to restraints or constraints, there are two types of routine protocols are started or are proposed. One is a proactive routine protocol, and one of the example of a proactive routine protocol is RPL. And RPL include WSN node and the local border router, or simply called LBR. And RPL uses a new concept of directed acyclic graph, or simply called a DAG, D-A-G. A DAG is separated into a multiple destination-oriented DAG, or called DODAG. In this, where the root of this DODAG are normally the LBR, which are border routers. And in contrast with the proactive routine protocol, we have another type of routine protocol, which is called a reactive routine protocol. By looking at the name, we know that reactive routine protocol, normally you don't have a routine table or a path, and only this routine path or table will be discovered only when you have a need to send data. And as now we just mentioned, ADOV was popularly used for the MANET network, and there are some AODV-like protocol has been developed for the wireless sensor networks. Here we said AODV-like. They are not exactly AODV, but they adopt a lot of concept or ideas from the traditional AODV. And this kind of protocols include LOAD and LOAD-NG. By the way, both LOAD and LOAD-NG are based on the principles of router request or router reply for the route discovery. Now let's move to next protocol, which is the 6LoWPAN protocol. This protocol has been added later on to the protocol stack, which mainly is used to integrate the IPv6 address schema into the low power networks, and the low power networks such as IEEE 800.02.4 networks. As you can see here, you have a gateway and the bottom, and there are two distinct approaches for forwarding your packet in this layer, and they are mesh under or route over. There are some simulation has been done, and the simulation found out that the route over approach is more efficient than mesh under. We are not going to spend time to talk about this two forwarding approach here. Now let's look at the IEEE 802.5.4 protocols. As we know that the most relevant communication standard for the WSN 802.15.4 normally operate in low rates WAN time or wireless personal area networks, or simply called LR WAN. The IEEE 802.15.4 MAC spec and the IEEE 802.15.5 spec are standardized by the Zigbee consortium. The Zigbee standard have provided the mesh capacities for the IEEE 802.15.4 specs in its network and or security layer, and also in the application framework. So also all the Zigbee nodes require IEEE 802.4.15 and IP gateway to communicate with the IP networks. Now let's move to the implementation of the wireless in healthcare. As here, the implementation of wireless sensor network in healthcare mainly based on using the network simulation technology. And currently there are many network simulators which have been used to implement the WSN networks. These network simulators include NS2 and Koja and TOS-SIM and Omnet++ and Castia and others. But we choose NS3 only because RPL and 6LoWPAN and LRPAN have been available to us to use for free. By the way, there are three categories of Zigbee networks, And the ZigBee, this includes ZigBee coordinator, ZigBee router, ZigBee devices. The ZigBee coordinator is used as the interface between IP networks and the LRY-PAN. Once you come to the S3 network simulator, the essential things is to design your node. So the node contains a number of containers, and they have an application and the interface container, and also net device container. And in each application, in each container here, you have to specify which protocol you will be using. By the way, NS3, there is virtually a module library, and where various communication networks can be designed. And then by using this simulation on NS3, we can configure the WSN for the healthcare. For instance, in this system, we have 4 nursing homes, nursing home number 1, number 2, number 3, number 4. And you also have a gateway. And in each room, you have your own router here, and a router here. And all this router will route their data, collect the data from this room into the gateway. And this is an implementation. We have implemented this system on the NS3 networks. The system is workable, is ready at the moment. Okay, so I will have a simulation animation. So in this work, we have developed a framework. We proposed a framework, and in our research, we have analyzed the requirement and the characteristics of the healthcare systems, and we proposed a framework on which the WSN-based healthcare system applications can be implemented, and the healthcare system has been configured in 2 scenarios. And also, we have implemented on the NS3 simulator, but we haven't done too much performance analysis, and also we haven't addressed the kind of attack where all the wireless sensor networks could suffer. There are warm attacks. So in the future, we will do some more research to addressing the warm attacks. That's all for today. So I'm going to show the simulation here. And you can see all the sensor in the rooms will collect the data and send it to their own router. And this router will always route their data, collect data from this red dot. Red dot is a sensor network, and deliver to the gateway. So this data always go to the gateway. All the information in each room will send it to their router. So they are sent to their router, and also this router will route all their collected data to the gateway. Yeah. So okay, so stop. Yeah.
Hello, let me introduce myself first. My name is Erdinç Türk. I work as a research assistant at Akdeniz University. I am also a member of ComNet's laboratory. I am going to present our study, Active Noise Cancellation for IoT-Driven Electronic Stethoscope, which is a comparative study of adaptive filters. We have been mainly studying on bubble activity detection for years. So far, we have developed electronic stethoscope prototypes in order to acquire bubble sounds. The figure on the left shows our first prototype design, and the figure on the right shows our second prototype design. Both prototypes transfer the signals via a cable. This is our third and last design so far. The figure number 1 shows the IoT-driven electronic stethoscope. Its size kept as minimum as possible. And the figure number 2, this one, shows the receiving device, which is connected to a computer. The ZigBee, a ZigBee module was used for signal digitization and wireless data transmission in this device. This module has 10-bit analog to digital converter, and signals are digitized at 5 kHz sampling frequency. A battery powers the system for 18 hours in the communication state. In the bottom side of this stethoscope, we have a diaphragm and chest piece. In order to acquire bubble sounds, an electret microphone is placed into the chest piece. But ambient noise occurs in clinical environment observed and classified as bubble activity. Therefore, a second microphone is placed in the opposite direction to observe only ambient noise. Our main purpose is to increase bubble activity detection accuracy. Real-time detection of bubble motility is important for patients' healing process. Bubble sound detection is challenging due to the ambient noise in the clinics. That's why adaptive filters are used for active noise cancellation. In this study, active noise cancellation simulations are performed in order to compare performances of adaptive filters based on the design of our electronic stethoscope. In this slide, an overview of our methodology is described. The method of this study is divided into two parts. We observed that ambient noises acquired with two microphones are different. That's why in the first part we identified the electronic stethoscope system in order to find out this difference. And in the second part, active noise cancellation simulation environment is described. In order to make simulations, synthetic auscultation data was generated for 4 cases to assess the filter performances in different situations. And then active noise cancellation performances are calculated for 5 most widely used adaptive filters, which are LMS algorithm, normalized LMS algorithm, affine projection filter, recursive least square algorithm, and lastly adaptive lattice filter. Adaptive filters are widely used in signal processing applications. One of them is active noise cancellation. The figure on the top right side shows adaptive filter scheme for our active noise cancellation application. The adaptive filter updates digital filter coefficients in order to minimize error signal, which is the difference between the desired signal and the output of the adaptive filter. For our electronic stethoscope, the first microphone which is located into the chest piece, assigned as the desired signal, and the second microphone, which is located in the opposite direction, that observes only ambient noise, used as the input signal of the adaptive filter. In this application, error signal is the output of the active noise cancellation. As it can be seen from these equations, the desired signal consists of bubble sounds, altered ambient noise, and the background noise. Background noise is usually caused by electronic hardware. And the input signal which is assigned as microphone 2, consists of original ambient noise and background noise. Due to the shape, orientation, and structure of the chest piece, the first microphone observes noise different from the second microphone. This difference represented with the channel block in this figure. In order to generate synthetic data for simulations, this response must be identified firstly. In order to estimate channels properties, we used RLS adaptive filter. 6 different digital filter lengths are tested, from 8 to 256. And our aim is to find out the optimal number of filter length that represents the system. In order to identify channel response, we placed the electronic stethoscope on the subject's abdomen and applied 1 second long signals comprising 0.2 seconds long impulsive noises. And impulsive noises in this study are created using the white Gaussian noise model, since it is a basic model to represent any random noise that occurs in nature. The figure on the bottom right side shows an example of acquired signals and error signals of adaptive filters with different digital filter lengths. As it can be seen from this figure, the ambient noise observed with the microphone 2 is different from the signal observed with the microphone 1. The power of the error signal, the correlation between the output signal and the desired signal, and the computation times were calculated to evaluate convergence performance. The table on the left shows the performance assessments for system identification. The results here are reported as mean value plus minus standard deviation value. The performance of adaptive filter increased by the filter length. Considering the convergence performance, adaptive filter with the length of 128 is determined to represent the system. The figure on the top right side shows the average filter coefficients that represents the system, and this figure on the bottom shows the magnitude and phase response of the electronic stethoscope. We can see that some signals up to 500. We can see from this figure that some signals up to 500 Hz were amplified and others were attenuated. Since we identified electronic stethoscope response, we can generate synthetic auscultation data. For this, we designed 4 different simulations, as shown in the table below. For each simulation, different synthetic auscultation signal is generated for both microphones. In this simulation, signal parameters were determined based on the observations of the real auscultation records taken with the electronic stethoscope. These parameters are shown in the table on the top. Sampling frequency was set to 5 kHz and observed bowel sound signal was measured around 20 dB, and the duration of the bowel sound signal was 40 milliseconds. And generated impulsive noise, the power of the generated impulsive noise 20 dB, and duration of the impulsive noise was 0.2 seconds. In this page, we can see example signals generated with these 4 signals. An overview of simulation scenarios are shown in this table on the top right side. In the first simulation, a single impulsive noise was generated to measure convergence speed by using mean square error values. This is an example of generated signal in simulation 1. In simulation 2, 60 seconds long signal including 10 impulsive noises was generated. An example generated signal for the second simulation is shown in the figure top right side. In this simulation, background noise was also added to these signals. The purpose of this simulation was to compare adaptive filter performances against random impulsive noises where vowel sound do not exist. In the third simulation, this time we used vowel sound signals. The purpose of this simulation was to compare adaptive filters against random impulsive noises where vowel sounds exist, and also check if adaptive filters causes any corruptions in vowel sound signals. And finally, in the last simulation, this time we didn't use background noise. The purpose of this simulation was to compare filter performances against random impulsive noises where background noise is absent, and check also if adaptive filters cause any corruptions in vowel sounds. Each active noise cancellation simulation was performed 100 times in order to obtain accurate results. The figure on the right here shows the average mean square error obtained from the first simulation. We can see that RLS and adaptive lattice filters reached the minimum mean square error value around 150 samples, which is the fastest among others. Performance results of adaptive filters were reported as mean plus minus standard deviation. For the first simulation, power and the standard deviation of the average mean square values were calculated as shown in this table. Small power and standard deviation value mean faster convergence. So RLS and adaptive lattice filter converged faster than other adaptive filters as shown in the previous slide, and although RLS filter showed better performance which has lower power, adaptive lattice filter I will repeat this sentence again. Although RLS filter performed better, it has a significantly higher computation cost than adaptive lattice filter. The second table shows the results for simulation 2. Mean and standard deviation of the computation time and power of the error signal are calculated, and in this simulation LMS and adaptive lattice filter algorithms attenuated ambient noise effects significantly better than the others. The table on the bottom left shows the results for simulation 3. In this simulation, adaptive lattice filter attenuated ambient noise while preserving bubble signals better than the others. Higher correlation value means less corruption in the bubble sound signal. And the last table shows the results for simulation 4. In this simulation, LMS filter attenuated ambient noise while the preserving bubble sound signals better than the others. In this study, we evaluated the performances of adaptive filters and performed simulations for our electronic stethoscope. The findings of this study showed that adaptive lattice and LMS filters perform better than the others. In terms of computation, the LMS algorithm is less demanding, but the downside of the LMS is it doesn't have any adaptive step size control and sometimes converges to unstable filter coefficients that results in outlier values. As a result, the adaptive lattice filter algorithm is selected for active noise cancellation for bubble activity detection applications due to its high noise reduction performance and moderate computational cost. For future studies, the active noise cancellation application will be implemented in C language, and we will run the application using the developed electronic stethoscope in real clinical environments in real time. This is the end of this presentation. Thank you for listening.